It's a real pleasure to be here in Norway for all sorts of reasons. This is, I think, my 7th or 8th trip to Norway. It's such a beautiful country. Stavanger's a new city for me, but I always enjoy coming here. Lovely people, lovely country. It's always difficult talking about this subject, openEHR. It's something that's dear to my heart. It's what I've been doing professionally probably for 10 years now. But it's not an easy idea to get over to people. It covers a broad range of quite revolutionary ideas that everybody who comes to it finds a little tricky to understand. But I wanted this morning to try to give you a flavor of why I think some of the ideas behind openEHR are the way that all health software systems will be built in the future. And Norway stands in a very special place in the world at the moment because of the commitment of companies like DIPS particularly, but there are other Norwegian companies who are using the same technology, and commitment at national level. Silje Bakke is here from the National Institute that are looking after some of the modeling activity that I'll talk about. And there is something interesting happening here where we've got a really interesting combination of things coming from the center, from government, from health institutes, from academics, and from industry. And I think it's a model that the rest of the world will follow. It may not be the pure openEHR way that we talk about today. You know, technology moves very, very quickly. But I think in 10 or 20 years, most health systems will be built this way, not the way traditionally. So, a little bit about me. I'm a former GP, family doctor in Scotland, Glasgow. I fell in love with little computers when I was a student, and that became a bit of a career. So although I practiced for a number of years, I haven't been in practice for 16, 17 years now, and have really spent the rest of my time doing health informatics, doing general bits of work, not just openEHR related, but recently I became the co-chair of the openEHR Foundation, which is the not-for-profit organization that looks after parts of openEHR. I'm also a bit of a hacker. I do like to do a bit of programming. I'm not very good at it. I'm a bit of a hacker. But I did have a weird diversion into writing commercial software for a while. So I know enough about it to know how to do it badly. And I also understand that I'm not a professional. You know, I can get myself lost and I get stuck. I can speak to software developers and we kind of understand each other. But I know when to stop and get out of the way. I discovered whiskey late in life, which is very sad. I tried very hard as a good Scotsman to enjoy whiskey every 5 years. Terrible. And then I discovered the really good stuff, you know, the really expensive stuff. And now I'm a fan. I can even drink Irish whiskey, which is not so good stuff. Okay, here's the problem. And it's something that people come to late. So at the moment, you know, everybody and his brother is starting up a healthcare app company. Small companies, new companies, guys come out of university, they speak to their mate who's a doctor, and they say, we've got a great idea for an app. And they build a little app, and it works well, and it looks really pretty. And then they get into this problem, that healthcare data, the stuff that we all work with in healthcare systems and in practice, is just nasty. It's difficult. It's complex, it's complicated, it keeps changing all the time. It's biological, of course, but only partly. A lot of the things that we record in health records and the health record systems is cultural. It's how we do our work. It's how we interact with our patients and our colleagues. And of course, in every country around the world, it's intensely political. Every time the government changes, there's a new initiative. There's new kinds of data to be recorded. And that doesn't matter whether you're in the US or the UK or Norway or Australia. It's the same everywhere. Healthcare is such a major part of any company, any country's economy. Again, whether it's privately funded or publicly funded, as in the UK, it doesn't matter. It still represents a major expenditure. So inevitably, politicians, policymakers have a big impact on the way we think and record healthcare data. And the last thing is really tricky. Getting a good understanding of what clinicians need is very, very hard. It's very, very hard to understand what the screens look like and doing good UI. But getting a hold of those clinical ideas, the clinical concepts, what Thomas called the semantics. What do you mean? What do you mean by blood pressure? It's hard. And traditionally, every single little company, every single big company, has asked those questions of clinicians over and over again. So, just as an introductory, some ideas to throw at you. This is a very simplistic way of looking at how health systems are put together. We've got the application at the top, the bit that we all see and work with. And in the previous presentation, that was what we're largely seeing, screenshots of data entry screens and reporting screens. But under that, there are two layers. The one that most people understand and know about is the persistence layer, the database layer. So, people, even those who don't understand much about computers, understand that somewhere that data goes and it gets saved somewhere in a file or in a database or somewhere in the cloud. And that obviously has to be in some kind of structure. Most people are not aware that this bit in the middle called the information model, that's the thinking bit of the system. But it's often something that is overlooked. So what is it? It's the bit that's really used to manipulate information in the computer's memory. And I appreciate some of you here are probably technical and going, this is what he's talking about. But I'm trying to keep it straightforward for the majority of people. The information models are generally written in a specific programming language, and they're generally locked into each application. And they're not easily shareable. So this is one application's idea of what a blood pressure looks like. It has a systolic with a value of one value and a unit. It has a diastolic. It has a time, what they call effective time frame. It has something about body posture. And it has something called descriptive statistic. I don't really understand what that means. Every single application around the world will have, if it records blood pressure, will have a little information model like that. Those information models don't appear by magic. They appear because they come to ask someone like me as a doctor, someone like Celia as a nurse, and say, what's in a blood pressure? What is it you need? And that means that every way that blood pressure is captured in this information model is different in every single one of these systems, virtually. That is a huge waste of energy. It's a huge waste of resource. And it also means that when they ask me as a doctor what I mean by blood pressure, and they ask Celia as a nurse what she means by blood pressure, we're quite likely to get subtly different ideas. And then we wonder why systems can't talk to each other. And we shout at our technology colleagues and say, the technology's terrible. I can't get my machine to talk to your machine. It's not their fault. It's our fault as clinicians, because we don't give them the right requirements. We don't explain what it is, and we don't share, and we work in silos, and we don't know that we work in silos and think in silos. Information models power the internet. The glories of all of the fantastic apps that we have on our phones, any of those that connect in any sensible way with the internet almost certainly use an information model. Anybody have an idea what this might be? Uber. Uber has an API, an application programming interface. Just means how Uber talks to the rest of the world. And you can go and look it up. And this, when you ping, you've got Uber in Oslo, all right? It's great fun. It doesn't feel right to use it, but it is great fun to use. And basically, if I contact Uber and say I need a taxi, it sends this little message to the Uber servers, and then they do all their magic. And this is the data coming back. It's a request ID. It's got the phone number of the driver. It's got my location. It's got the driver's location. It's going where I want to go. Everything that you see on your phone, like that, is driven by little bits of structured information model data. That's how computers work, effectively. At least modern computers work. But we have a problem in health because our equivalents are much, much more complicated. So here's an example of medication orders. The name, the route. And then we've got this problem of how do we do these very complicated dosages? 1 tablet 3 times a day for 4 days, then 2 tablets 4 times a day for 5 days, then indefinitely. So we have a much, much harder job in health and in medicine to represent information in a way that people like Uber or the banks don't have. So we shouldn't beat ourselves up too much. This is a difficult problem. So traditionally, systems are put together like this. And I guess legacy DIPS, previous version, would be an example of this. But virtually every other application in the world works. That's what Gartner once called a mega suite. you get everything. You get the application, you get the information model, and you get the database, all in one package. You get the lot. The company that supplies this and builds this gives you everything. And the problem is, of course, that everybody's doing that. So these information models are all different. And that's where we have this problem of both a difficulty in interoperating between these systems, but also a huge amount of duplicated effort of people in all of these different little applications or big applications struggling with their clinicians to define a medication order or a blood pressure or a procedure. How do people try to tie this together? Well, traditionally, they call best of breed. Okay, so you say, okay, we'll use an integration engine, we'll use messages, we'll use transforming, we can make your version of blood pressure match up with my version of blood pressure. Well, yes, you can in theory, but it turns out to be incredibly difficult to do. And again, that's because this is complicated clinical stuff. The ideas that people are trying to reprogram actually require a lot of clinical inputs. It's expensive to do and it's risky to do. And so although there's a big industry trying to tie together all these different MegaSuite applications, they haven't worked that well historically. It's not really takeoff. It's too hard to do and it's too expensive to do. So we're now starting to see the emergence of what I call best of breed 2. Thomas is quite right. I stole best of breed 2 from him and then I changed it. But that's progress. So things start to look a little bit different in the best of breed 2 world, which I've called closed platform. On the top, down the bottom, we've got exactly the same arrangement. We've got the information model and the persistence model, or persistence layer, come from a company or a service. So you buy that. But on top of that, you can have as many different apps as you like, and they're tightly bound to this platform at the bottom, supplied usually as a service. You'll recognize that as how Apple work. Okay, that's the Apple way of doing business. Down the bottom, you've got your iOS and your iPhone or iPad, and then you have as multiple applications as you like on the top. And it is a much better way of building software. We can see how quickly you get innovation in that top layer, lots of new apps. And of course, we want to try to mimic that in health and get this working. So we are starting to see a lot of companies now going into this kind of market and saying, we have a platform that we will sell you, and then we'll give you some applications, but you can build others on the top. And even big companies like Cerner are now changing their business model to effectively reinventing themselves as a best-of-breed 2 platform company. And here's an example just to show that this is real. This is a group in the States who have this idea of smart on FHIR and clinical models. And don't worry about the details, but this is effectively the best of breed 2 approach. And it is something that these major companies and organizations are taking very seriously and re-platforming themselves. Instead of being MegaSuite vendors, they're now starting to become best of breed 2 platform vendors. With openEHR, we're trying to do something a little bit better, different, more sophisticated, which is what I'm starting to call best of breed 3, and it's an open platform architecture. Effectively, we start with the same thing. We say, okay, we want the app layer, but we don't want to be locked into one vendor at the bottom. Okay? We need innovation in the storage layer as well. New database products, new kinds of operating system, new ways of working are always coming through. We want that to keep changing. We want innovation at the top and we want innovation at the bottom. But we need to have something in the middle that glues that together, the standards, the standardization layer. That's what openEHR or openEHR, it's the same thing, is trying to do, is to act as the glue layer between very dynamic changing services at the bottom and a nice dynamic apps layer at the top. And it's based around some simple APIs, querying language, and this whole infrastructure that I'll talk about in a second. And the idea is that you can build your app, and you build it on the openEHR layer, but then at the bottom, you could have multiple different vendors providing those services. You can change from one company to another, You don't have to change anything in your application. You don't have to change the way that it works. It's just a service. You can swap one thing out very easily. And we know that a number of vendors have done that. In fact, DIPS did something similar while they were developing DIPS Arena. So we know that this works. And of course, there's lots of options of these CDRs, clinical data repositories. These are really smart databases. They're databases that understand that openEHR middle layer. And of course, that's exactly what DIPS have. They have built one of these CDRs, and a CDR, DIPS Arena is based on DIPS eHR, and DIPS eHR is one of these smart CDRs. The other part of this, and one of the big ideas in openEHR is to say, clinicians, we need your help. We need to do this very hard job of working out what these information models are. What's a blood pressure? What's a procedure? What's an allergy? We need to do it in common. We need to do it collaboratively. And we have to expect that it will be a bit of a messy exercise because it takes time and energy and commitment to develop these models. But we won't do it unless we get clinical people directly involved. Because complex things like medication are complex because it's clinically complex. It's not a technical issue. Just, the way that medication works, the way we have to describe it, the different uses that we put a medication model to are just inherently complicated. But it's our business. It's not the business of the technical guys. Definitely, we want them to come and help us build these things. But ultimately, we as clinicians have to work out what these things look like so that we can move medication models around, move medications around. They should be fit for use by pharmacists, by nurses, by doctors. So, what's openEHR? openEHR is a not-for-profit organization. It's based at University College in London at the moment. And it is really a very small, lightweight organization, and its main role is just to look after the intellectual property. And that is all open sourced. It's all free to use. The main aim of openEHR is really to provide specifications. It doesn't build software as such. It just provides the blueprints, manages the blueprints, updates them over time to take in new ideas from companies like DIPS and others. And it is all about providing the specifications for this open platform idea, the best-of-breed idea, and to make sure that any system that's built on openEHR, the data is completely exchangeable, regardless of the human language. So the models that we build are purposely designed to be internationalizable. So we have Norwegian translations, we have Chinese translations of blood pressure, the same idea but in multiple languages. Regardless of programming language. So DIPS is a .NET house, use the Microsoft .NET, but we have many, many other examples of people using different programming languages and programming frameworks. And regardless of the internal database technologies, it doesn't matter whether you use SQL Server or Oracle or Mongo or some of the new NoSQL engines like Cassandra, it doesn't matter. An openEHR system at the level of the way that the application is built works exactly the same way. So we've got that flexibility to choose. We don't have vendor lock-in and we don't have technology lock-in. How do we populate these systems? Well, we do it by building these little things we call archetypes. So they're little components that reflect parts of a medical record. We build them open source, we share them, we try to collaborate on the reviews and invite clinicians and other interested parties to comment on them. And they're tight little components, a blood pressure, a medication order, a body weight, family history. And when we're building these things and designing them, we adopt a philosophy called the maximal data set. In other words, we try to get as many perspectives as we can into the archetype so that we can capture the differing needs of nurses versus doctors versus patients. And that way, we try to get the best requirements we can when we build these things. But understand that, if you capture all these requirements, we're not asking everybody to collect all that same data. People will pick and choose the data points. If nothing else, it's a conversation space for us as clinicians to understand the varied ways in which we work and to understand some of the reasons that we can't get our systems to interoperate, which is down to the way we work and not the way the systems work. But openEHR is primarily about supporting app development. The reason we have this openEHR specification layer, the reason that we have the archetypes, is primarily so that we can build better, quicker, safer applications. And here's some examples. openEP is an open-air system, e-prescribing system that's about to go out in the UK. This one down here is the infection control system built by an Australian company. This is a project that I'm involved with in the UK, an open source application development, health application development called Ripple. And of course, this one you're familiar with is DIPS Arena. How do we do this clinical content development? Well, fundamentally, it's built just very often with people within companies or within organizations say, I need a cancer score. So we build a cancer score using some little tools, archetype tools. They're pretty easy for clinicians to use, although it would normally be people like myself or Celia that actually do the archetype building. Having built these, we put them up into a shared space, a repository, and this is a tool called CKM, Clinical Knowledge Manager. And Norway has one of these, archetypes.no. See you in a second. This is one in Brazil. This is one in Australia. This is one in the UK. This is another one in the UK. Politics. This is the international one, and the medication order that I've just put up last week after a lot of pestering from colleagues in DIPS, because they said, you're doing it too slow, you're doing it too slow, because they're relying or wanting to work in a collaborative way. There'd be nothing to stop DIPS saying, Ian, you're too slow, we're doing our own thing. But they understand and appreciate the value of trying to do this once and sharing those ideas as far as possible. Now, it's never perfect. We know that there are parts of a medication order that will have to be Norway-specific because there are parts of the prescription ordering system and some of the security criteria around prescriptions, which are always going to be different in every country in the world. So we have places where we can plug in locality specialist bits of archetypes, little sub-archetypes that let us shape the main one to work in a particular country. So there are little Norwegian add-ons, and similarly we've built little UK add-ons because we want to use the same archetype in the UK as well. So here we go. National IKT. Bartel index went up 2 weeks ago. No, ages ago. Oh, a year ago. Oh, I'm behind the scenes. It was the international one we put up. No. Braden score. I knew it started with B. Never mind. Okay. So this is about collaboration. We use these tools, the CKM tools, to put the archetypes up in a published space and then ask people to review and comment on them. And the whole tool is designed to make it easy for people like myself and Celia to manage that process, to feedback the ideas that I've had. We collate the ideas, we adjust the archetypes, we put them back up on CKM for another review cycle, and then when we think they're good enough, we publish them. And that says to the developers, such as DIPS and the other companies, other open source companies, to say it's good enough to use. And then it's very carefully versioned and controlled. So the guys who are in the software side of the business, we have to treat these like software components, because when we built them, we can plug them straight into an openEHR system. Just to let you see, if you remember back to that slide where we talked about the best of breed 2 and the idea that's emerging in the States, that HSPC diagram, the smart on FHIR on openEHR, on clinical models. So this is a project that I'm involved with in the UK, part of the NHS Code for Health. And you can see this is the vision, that we have a number of different open APIs. Down at the bottom, we have one of these openEHR CDRs. Could be DIPS Arena, why not, a DIPS EHR. But on this side, this is all powered by clinically driven content development. Okay, so this feeds into and builds the systems. How do we, if we have a new requirement for some kind of cancer score, it's done by these guys and then it plugs into this infrastructure. So this is the big difference. This is what's different about this way of the world. It's how systems get built. Because traditionally what will happen is, clinicians will come up with a requirement, they probably have a discussion with the business analyst, then there's discussions with the user interface designer, the technical modelers get the requirements, the database developers get the requirements, they run it around a few times, and then they develop the application. And of course, things change. The first round of requirements wasn't quite right, or the clinicians aren't happy with something. So we go round and round that fairly complex cycle many, many times. And of course, every single system does it the same way. So we got a huge amount of work. Building Best of Breed 3, which is what's going to be different for you guys as Arena takes on, is all about trying to build that complex bit of the information model as few times as we can, and lots of people can share it, including multiple different apps developers. So as well as DIPS developing this kind of system, there are at least 3 other Norwegian companies who are intent on doing the same thing. And they're building, sharing the same information models. They are competing with DIPS at one level. They would expect to be both collaborating and competing. So it's a new kind of world, both technically and commercially. And of course, Archetypes.no is vitally important in pulling that together and trying to get good national and international communal models. So those of you who are clinical, who have an interest or domain, please get involved in this space. So big ideas: free the data. I think Thomas said something like that yesterday. Commoditize this complex clinical data handling. Take some of the pain away for these app developers. And critically, clinically driven content definition. That's what openEHR is trying to do. Thank you.
Thank you so much, Ian. We have room for some questions, if anyone are wondering about something.
Hi, Catherine Mølstad, the Norwegian Nurses Organization.
Hi.
Thank you for an interesting, complex presentation. What I'm wondering is, how are we going to get the clinicians to think this is interesting in order to build the clinical content? Most nurses don't know anything about archetypes, and as I understand it, it's most people will not have this as part of their job. So.
Sure.
What's your experience concerning this?
Okay, so you're quite right. Most nurses, actually nurses are much better at doing this kind of stuff than doctors, I have to say, in my experience. They're much more patient in terms of thinking about data. But yeah, you're right. We don't expect the vast majority of clinicians to get involved, and we don't need to. We need to get a number involved who find it interesting. And what we're asking them is just to say, look at these things. Does it capture the kinds of information that you want to work with? When you see the tool and you work with the tool, they're not asked to build archetypes. We put up some candidates and say, look, here's what blood pressure looks like. Does that work for you? So once we get people involved, and they need a little bit of training, but once they get involved, it's not difficult to get people, even who have really no technical skills or technical interest, to get engaged, because they do understand that getting this bit right is ultimately important to the way that the systems get designed. So we need to do education, we need to engage people, and I've been doing a lot of workshops around the UK to do exactly that, and I know Silja does the same in Norway, because it is an unusual thing. You're right, I understand the question. Getting people to understand that there's this thing called an information model which matters is not easy, because it's hidden. But it's what drives, it's what makes the internet work. And we know how successful that's been. If we don't get the same kind of thing going in health, we will always struggle to build good quality apps and to have good interoperability.
Other questions?
Thank you also for a very good presentation, very interesting. I'm in the board at DIPS now. I used to be a politician, and I've worked also with politicians taking decisions of doing new things, going into ICT and try to develop the good systems. But when you are giving this presentation, everything seems so easy, but it's not merchandise in a grocery store. So I wonder, can you say anything about security, of the security levels? It seems so easy that everything is open. And
Okay.
it's not like that, I know that,
Sure,
but
sure.
please.
Yeah, sure. So, just to be clear, there are bits of this environment that are open source and bits that are optionally open source. So all of the models and the specifications have to be open, because otherwise nobody can build against them. And we believe that sharing the clinical content definitions is a critical part of building this community. But that doesn't mean that the whole application has to be open source. So for instance, DIPS are using this within a normal commercial product, as are most of the other companies, in fact. There are some examples of pure open source. But open source doesn't mean security is less. It shouldn't mean that. In fact, people argue that it's better because other people can look at the code, examine it, and test it for flaws. And in fact, most of the big security foul-ups happen within closed-source systems. That's a whole other discussion that I probably don't want to get into in great detail, but I think it's wrong to imagine that open source itself leads things to be less secure. It's still up to an application vendor, it's still up to a contract between a consumer and somebody implementing the system to make sure that exactly the same quality of code, exactly the same quality of security is in place.
Thank you. I think we're about on time, a few minutes over. National ICT is running Archetypes.no. Silje is here right now, I can see you. If you want to get involved, talk to Silje or go to Archetypes.no, because it's what Silje usually calls a duocracy, which means that if you want to get involved, you're invited to get involved, and we're happy to see you there. So do that. It's an investment for the future. Thank you so much, Ian.
Thank you. Very kind.
This is for the water, which you may or may not use for your whiskey.
That's a whiskey glass where I come from.